Hello and welcome to Calculus. In this last lecture of the second unit, we're going to revisit the economics function we studied in the first unit, the marginal cost, marginal revenue, and marginal profit. We are going to redefine them in light of differential calculus. Let's begin by recalling these functions. So the cost function, you remember, it's denoted with a capital C, the revenue function with a capital R, and the profit function with a pi. Okay, so let's assume the variable is the number of items produced, Q, okay, like that. And we define, from this function, we define the marginal cost, MC, at the level of production Q. Remember, Q is also called the level of production. We define the marginal revenue, and we define the marginal profit with C, R, and pi. How do we define this function? Very simply. The marginal cost is the cost of producing the Q plus 1 item, okay? The Q plus 1 item. So how do we get this cost? Well, that's very simple. Suppose, here's a line. Suppose this is the cost of producing Q item, the total cost of producing Q item, right? And suppose, so this represents the cost of producing Q item, the height of this segment right here. And suppose the height of this segment represents the cost of producing Q plus 1 item. What is the cost of producing the Q plus first item? Well, it's going to be the difference right here between the two. This right here is a cost of producing the Q plus 1 item, okay? The Q plus 1 item, the single Q plus 1 item, okay? And so we defined the marginal cost at the level of production of Q to be the total cost of producing Q plus 1 item minus the total cost of producing Q item. And the same is true for the marginal revenue, okay, at the level of production of Q. It is the revenue from selling Q plus 1 item minus the revenue from selling Q item. And the same, again, will be true for the marginal profit. It is the profit from making and selling Q plus 1 item minus the profit from making and selling Q item. These were the exact expression for the marginal functions, okay? So now let's try to understand how calculus might change these functions. Okay, so you remember the forward difference of a function. Suppose you take the function y equals f of x. The forward difference, how did we define that? We define it to be f at x plus h minus f at x divided by h, right? And this is what we call the forward difference. Graphically, if you have a function right there, right? This is x right here. This is x plus h right here, right? And the forward difference would be the slope of this secant line right here. And when h is small enough, right? When h is very small, x plus h approaches x, then the forward difference is about equal to the slope of the tangent line. You remember that? So for small enough h, this forward difference is about the derivative of the function at x, right? And I use here sometimes a subscript for f forward difference right here. It's an approximation, okay? It's all an approximation here. It's not equal. So how does that forward difference would translate with the cost, revenue, and profit function? Well, let's see. If I look at the forward difference of the cost function, what do I get? I get C of Q plus H minus C of Q divided by H, right? But the cost function is what we call in math a discrete function. H cannot be 0.1. You don't make 0.1 item or 0.2 item, right? H is equal to 0, 1, 2, 3, 4, 5, right? It takes positive integer value, right? So the smallest value for H is H equals 1. So the forward difference with H equals 1 becomes C of Q plus 1 minus C of Q. And this would be an approximation for the derivative at Q. Okay, because the forward difference is an approximation for the derivative of the function. So the marginal cost appears to be very close to the derivative of the function at Q. Let's check out with one example how close this is. Okay, so right now I'm asserting that the derivative of the function at Q is very close to the marginal cost of the function at Q. Let's check it out with the first example. All right, so what do you have? You have a company that manufactures fuel tanks for automobiles. The total weekly cost in dollars of producing Q tanks is given by, here's the cost function right here. You remember, you see the fixed cost and you see the variable cost, right? Variable because it's got Q. Fixed because it doesn't have any Qs, right? No matter what Q is, you will always have this 10,000 right there. All right? Anyway, find the value of the derivative of C when Q is 500. So how do we get C prime at 500? Well, we use the calculator, right? We don't have the tools yet to compute that directly. So with the calculator, you remember, I'm going to put this function into y1, and I'm going to read the output of what y2 at 500. Let's do it. All right, so here's the calculator. Let's go to the y equals menu, and let's enter the function. So it's 10,000 plus 90, so Q, so it's going to be X, of course, minus 0.05 X squared. Here we go. Here is my total cost. And in y2, of course, you have the symmetric difference, which is a very good approximation for the derivative. So now let's go where? Well, let's go on the home screen actually this time. Okay, so I'm going to go on the home screen right here, and I'm going to get the derivative at 500. So y2, y function, y2 at 500 right here. And so it is about 40. Okay, so I have that C prime at 500 is about 40. What's a unit? Well, what's a cost in dollars, right? So it's dollars per Q, so dollars per tank. Okay, so I'm not exactly sure why is this a unit, because it's a derivative, right? And the unit for the derivative is the ratio of the output, dollars, over the input, right, tank. I'm not exactly sure what that means, but let's check out the marginal cost for producing the 501st tank. So it's a marginal cost at the level of production of 500, which is the cost of producing 501 tank minus the total cost of producing 500 tank. Let's check it out with the calculator again. Okay, so I need y. So this time I want the total cost, right? So it's y1, right? y1 at 501 minus y1 at 500, and let's see what that is. And it is 39.95. You see how close these two numbers are? So it is about, so actually it is exactly $39.95. What does it mean? It means if you want to produce the 501st tank, it's going to cost you $39.95. Okay? While right here, we had this $40 per tank. Now this number is close to this one, and therefore we justify the definition I'm about to show you. Here we go. These are the new definition for the marginal cost, marginal revenue, and marginal profit, okay? We're gonna say it is a derivative of the cost, the derivative of the revenue, and the derivative of the profit functions, okay? So if you take the derivative, you're gonna find the marginal. So let's see how these definitions work in the next example. Here we go. Check it out. The graph of the cost function is given below. The blue segment represents the portion of the tangent line at Q equals 30, 80, 120, and 180. These are level of production, okay? Does it cost more to produce the 30th, 80th, 120th, or 180th item? At approximately what level of production is the marginal cost the smallest? What is the total cost at this level? All right, so it's about the marginal cost, right? Because I'm asking you, does it cost more to produce the 30th, 80th, 120th, or 180th item? So it's about the marginal cost. And the marginal cost is the derivative of the cost function. And this is represented by the slope of the tangent line, right? Slope of tangent line. So does it cost more to produce the 30th, 80th, 120th, or 180th item? I'm just going to check the slope of the tangent line. Let's see. Okay, this is a pretty flat one, a little bit steeper, and this is the steepest. Therefore, it costs more to produce the 180th item. Okay, so this is the one that will cost you more. At approximately what level of production is the marginal cost the smallest? So actually I said more, but I think this is less than this, right? It seems steeper here than it is there, right? So I think I made a mistake. This is the level of production that's going to have the lower marginal cost right here. So I would say at 80. At 80, the marginal cost is the lowest, meaning to make the next item, it's going to cost you the least amount. Okay? And there was a question about what is the total cost at this level. Well, you just need to read the output of the function, right? So at 80, the output of the function seems to be about, I would say about maybe $27,000, right? $27,000. Let's move on to the third example. Okay, so this is a weekly cost to produce Q widgets. Right here, here's a cost right there. Again, you recognize the fixed cost and the variable cost. They contain a variable where Q is between 0 and 200. And the demand function, this is another visitor from the past, the demand function, where P is a price of one widget and Q is a number of widgets, right? Fill in the table below to determine the marginal cost, marginal revenue, marginal profit at various levels of production. Assume that the company sells exactly what they produce. Of course, that's a big assumption, no stock. What level of production guarantees a maximum profit? Think of the geometrical meaning of pi prime of Q. I'm not sure what that means. We'll see when we get there, okay? So, how do we fill this table? Well, guys, I mean, you know that, right? I want the derivative of C right here, right? And therefore, I'm going to plug this function into my calculator, and I'm going to fill in this derivative value right there, okay? So let's start by plugging in the function. All right, let's go to y1 right here. Let's clear this, and let's plug in the function. So it's 16,000 plus 500x minus 1.6x squared, and then we have plus 0.004 x cubed, x power 3. Here we go. Here's y1. So now what do we want? We want the marginal cost at what level of production? 20, 40, 60, 80, 100, 120, 140, and 160. Okay, so I move by 20, starting at 20. So here's how I'm going to do it, right? So I'm going to check that my table set is on ask. Okay, yes, it is on ask. And now I'm going to go in my table right here, and I'm going to enter 20, enter 40, enter, 60, enter, 80, enter, 100, 120, 140, and 160 right here. All right, I should not have plotted y1. Here are the values that I will enter in my table, okay? Now, of course, right away, I see that something is definitely wrong with these values. They're all negative right here, and I have some like negative cost. Something is definitely wrong. I must have made a mistake when I enter my function. So, yep, right here, it's supposed to be 1.6 and not 16, you see? I mean, you always have to think a little bit, and I'm not very good sometimes with careless mistake. So let's insert a decimal point right here, insert decimal point, and let's check out the values now. And let's see what we have. These are much nicer value. Let's enter them in our table. Alright, so now we need to figure out the marginal revenue. So before we do that, we need the revenue. Now I hope you remember the revenue function. The revenue is P times Q. So what do we do with that? Well, I am giving you the demand equation, right? The equation relating the number of items you're selling with the price of an item. It's 1700 minus 7Q. So P equals 1700 minus 7Q, right? So what are we going to do with this? Well, we plug this expression of P into the revenue to have R as a function of Q, right? It's 1700 minus 7Q times Q, which is 1700Q minus 7Q squared. And so now I'm going to plug this into Y1, and I will have my marginal revenue by looking at the output of Y2. Okay, so let's plug this into Y1. 1700x minus 7x squared right here, and let's check out the table of values right there. Here we go. Here are my Y2s. So let's report these numbers into our table. Here we go. And now what? Well, now we have the last function, the profit, right? You remember the profit was the revenue minus the cost. Okay, so now let's enter the profit function into our calculator and read out the output of Y2 again. So it's a little bit tedious, but it's really simple. I'm going to enter C right here. So I already have R, right? So I'm going to minus this right here in my calculator right here. Right? So check it out. Let's go to Y equals. Okay, let's keep this, right? That's the revenue. And let's subtract from there. I'm going to subtract my cost. So minus, be patient with me with this. Okay, so minus the cost. And the cost is 16,000 plus 500x minus 1.6x squared plus 0.004x cubed. Here we go. Wait, let's close the parenthesis where I have to close it. Right here, x cubed. Here we go. So let's check out again the table of values. All right. All right. And here are my marginal cost. Let's report this cost in our chart. Alright, here it is. Alright guys, there's a couple of things I would like you to notice in this table. Look at the marginal profit at the level of production of 20. It is 979.2. Look at the marginal revenue, 1420, and the marginal cost, 440.8. Now let's take our calculator and let's subtract the marginal cost from the marginal revenue. So let's do 1420 minus 440.8, and we find 979.2. You see? So and you can check that it's true at any level of production. This number is the subtraction of the cost from the revenue, marginal cost from the marginal revenue, right? And that's why right here it is 0, right? So not only do we have that the profit is equal to the revenue minus the cost, but we also have in this case that the derivative of the profit is equal to the derivative of the revenue minus the derivative of the cost. We knew it was true with the exact expression of the marginal, right? We knew we had this with the exact expression for the marginal, but we just checked that it's also true with the derivative. So we're very happy about our new definition, right? Okay, great. And so now, how do you spot the best level of production? Well, what do you want for the marginal profit? Check it out. The marginal profit right here is positive, right? That means the profit is increasing. The profit is still increasing. The profit is still increasing. What does that mean that it's negative? It means the profit is decreasing. You see what happened right here, right? Here, you went from an increasing profit to a decreasing profit, and you found out that right there, the profit pi prime was equal to 0. Remember, horizontal tangent line. So what's the best level of production? Q equals 100 widget is the best level of production. Okay? And therefore, we state the following theorem without proving it, of course, right here. The maximum profit occurs when the derivative is equal to 0, or it occurs when I prime equals C prime, which makes sense, right? Pi prime is R prime minus C prime. We just noticed that, we didn't prove it, right? So if pi prime is equal to 0, that means that R prime minus C prime is equal to 0, which means that R prime is equal to C prime, okay? All right, there are 2 more examples in this video, number 4 and number 5. I'm gonna leave them to do in class, but actually I'm gonna ask you to answer number 4 in the video for me, okay, on Zaption. Thank you for watching.